A 26-year-old engineer collapsed in a Budapest park in 1882, reciting Goethe while his friend watched in alarm. The nervous breakdown that brought him there had left his senses so acute he could hear a watch ticking 3 rooms away, and the vibration of a distant locomotive caused him physical pain. Watching the sunset paint the sky over Hungary in that moment of fragility, he saw something that would dismantle Thomas Edison's empire, illuminate the world's Columbian Exposition, harness Niagara Falls for George Westinghouse, and build every electrical grid on Earth. The rotating magnetic field had revealed itself, and he drew it in the sand with a stick, knowing that nothing would ever be the same. That engineer was me, and what I am about to tell you is not merely history, but the hidden architecture of your daily life. That hum you hear when you stand near a transformer, or a fluorescent light, or a power substation runs at 60 cycles per second in America and 50 in Europe. That frequency is the one I chose, and it has been embedded in your infrastructure long enough to outlast every building in your city. You hear my decision every single day without once thinking to ask why. Most people flip a switch and accept the miracle that follows. Light fills the room, a motor spins, a factory operates, and they believe this is simple and natural and obvious. But can you explain why the current reaches you across hundreds of miles of wire? Or why Edison's system backed by J.P. Morgan's millions and the full weight of General Electric ultimately failed while mine succeeded? Or what Michael Faraday's discovery of electromagnetic induction in 1831 had to do with the phone charging in your pocket right now? You cannot explain any of that because you have never really asked. I could not stop asking. From the time I arrived as a student at the Polytechnic school in Graz, Austria, watching sparks fly from a demonstration machine, I saw something that troubled me to my core. A flaw sat at the very heart of how electricity was being used, and it was so fundamental that I knew the entire approach would have to be abandoned and rebuilt from first principles. The second year of my studies brought a Gramme dynamo from Paris into our classroom, and in 1877 it was considered a marvel of engineering, with its horseshoe-form laminated field magnet and wire-wound armature with a commutator. My professor, a brilliant man named Poeschl, connected it and demonstrated its operation for the class, and that's when I observed something that disturbed me. The brushes sparked badly against the commutator, which was not a minor inconvenience but energy being converted uselessly into heat and light at the very point where power should flow smoothly. Wear and deterioration followed that sparking, and it represented a fundamental limitation that would prevent electricity from ever scaling to serve civilization. My suggestion to Professor Poeschl was that it might be possible to operate a motor without these sparking brushes, without the commutator entirely. He looked at me with the patience reserved for students who have not yet learned the boundaries of the possible, and then delivered an entire lecture on why this could not be done. His conclusion was that while I might accomplish great things, I would certainly never accomplish this, because it would be equivalent to converting a steadily pulling force like gravity into a rotary effort, making it a perpetual motion scheme and an impossible idea. Instinct transcends knowledge, and I had a deep conviction that I was right and he was wrong. The same year, Heinrich Hertz began his experiments with electromagnetic waves in Germany. I wrestled with a different aspect of the same invisible force. Faraday had shown that a changing magnetic field induces electrical current, and James Clerk Maxwell had unified electricity and magnetism into a single mathematical framework. The foundations existed, which meant someone simply had to see what they implied. Understanding what troubled me and what consumed me for years requires understanding what electricity meant in that era. The prevailing system, championed by Edison and financed by the most powerful banker in America, was direct current, which flows in one direction steadily and continuously, like water through a pipe. Edison's Pearl Street station in Lower Manhattan opened in 1882 and delivered direct current to customers within a 1-mile radius, and on the surface this seems logical and simple. The question that puzzled everyone else was why anyone would want current that reverses direction, and what use could there be for a force that pushes and then pulls, that surges forward and then retreats. Here's the thing that Edison and his engineers failed to understand, the thing I understood from the very beginning. All energies in nature are cyclic. Look at the world around you, and you will see the Earth rotating on its axis while the planets orbit the sun. The tides rise and fall with the moon. Day follows, night follows day in endless rhythm, and the seasons turn in patterns that have continued since the formation of this world. Your neurons fire in oscillating patterns, which means the very thoughts you are having right now pulse through your brain as electrochemical waves. Your heart beats in rhythm, and even your DNA replicates in cycles of separation and rejoining. I did not invent oscillation, but simply recognized that electricity wants to breathe too. Nature operates in cycles and waves and alternations rather than straight lines. The heartbeat keeping you alive at this very moment is not a steady push, but a pulse, a rhythm, an alternation. Forcing electricity to behave in a manner contrary to the fundamental operations of the universe itself made no sense to me, and that question consumed me for years as a sacred vow, a question of life and death. I knew that I would perish if I failed to answer it. Difficult years followed that revelation. I left the Polytechnic without completing my degree, worked as a draftsman, then found employment in Budapest at the new telephone exchange being established there. The work demanded everything I had, and I drove myself relentlessly, devoting every waking hour to the problem of the motor while turning it over in my mind, examining it from every angle, constructing and operating devices entirely in my imagination. My method differs from other inventors in that I do not rush into actual work. When an idea arrives, I start at once, building it up in my imagination, changing the construction, making improvements, and operating the device entirely in my mind. Running my turbine in thought or testing it in my shop produces identical results for me, and I even note if it is out of balance, because there is no difference between the mental version and the physical one. Modern neuroscientists might call this eidetic visualization, a form of cognitive processing that allows mental simulation with photographic precision. All I know is that the machines I built in my mind worked exactly as they did when I finally constructed them in metal and wire. The strain of this work combined with the demands of my position brought me to complete collapse. My breakdown of the nerves surpassed all belief, and my senses became extraordinarily acute in ways that physicians today might recognize as hyperacusis and hyperesthesia. A watch ticking 3 rooms away was audible to me. A fly alighting on a table caused a dull thud in my ear, and the whistle of a locomotive, 20 or 30 miles distant, made the bench on which I sat vibrate so strongly that the pain was unbearable. Rubber cushions under my bed became the only way I could get any rest at all. The problem never left me even in this state. Back in the deep recesses of my brain sat the solution, but I could not yet give it outward expression. A dear friend named Antal Sigeti convinced me of the importance of exercise and fresh air for my recovery, and we began taking long walks through Budapest as my strength slowly returned. One afternoon that remains ever present in my recollection, we walked through the city park while the sun set over Hungary. I recited poetry, as was my habit, knowing entire books by heart, word for word at that age. Goethe's Faust occupied my thoughts, that magnificent work about a scholar who sells his soul for knowledge, and the glorious sunset reminded me of a particular passage. I spoke the words aloud in the original German. Sie rückt und weicht, der Tag ist überlebt, dort eilt sie hin und fördert neues Leben, o dass kein Flügel mich vom Boden hebt, ihr nach und immer nachzustreben. The translation runs like this. The glow retreats. Done is the day of toil. It yonder hastes. New fields of life exploring are that no wing can lift me from the soil, upon its track to follow soaring. The idea came like a flash of lightning as I uttered these inspiring words, and in an instant the truth was revealed. I saw it complete and perfect, with every detail visible in my mind as clearly as if it were constructed before me in brass and copper and iron. The rotating magnetic field, the polyphase system, the induction motor without brushes, without commutator, without the sparking and waste that had troubled me for 6 years. I drew with a stick on the sand the diagrams I would show 6 years later before the American Institute of Electrical Engineers, the organization that eventually became the IEEE, which is now the world's largest technical professional organization, with over 400,000 members in 160 countries. My friend Sigeti understood the drawings perfectly, but to me they were more than drawings because they were reality. I cried out to him to look and watch me reverse my motor, and then I did it, demonstrating with my stick in the sand how the field would rotate and how the rotor would follow. Let me make this concrete for you, because what I saw in that moment is the foundation of modern civilization. Picture multiple coils of wire arranged in a circle, with each one connected to a separate phase of alternating current. Building on Faraday's principle that a changing magnetic field induces current, I realized that as the current in each coil rises and falls and peaks and retreats, it creates a magnetic field that strengthens and weakens. The crucial insight was that because each coil connects to a different phase, each reaches its peak at a different moment. Consider 2 coils placed opposite each other, and when the current in one coil reaches its maximum while creating a strong magnetic field pointing in one direction, the current in the other coil sits at a different point in its cycle. A moment later, the first coil's current has diminished, while the second coil's has increased, and the magnetic field appears to shift and move from one position toward the other. Adding more coils arranged around a circle with each fed by currents that peak in sequence produces an extraordinary result because the magnetic field does not simply pulse in place, but rotates. It sweeps around the circle like an invisible hand, like the wave of sunset traveling across the earth as I described while reciting Goethe, like the earth itself spinning beneath the fixed light of the sun. The field rotates without anything physical moving, requiring no gears, no shafts, no mechanical linkages, just electromagnetic waves, phased in sequence and creating rotation from pure electrical phenomena. Placing a conductor in this rotating field, a simple metal rotor at its center, causes something remarkable to occur. The rotating field induces currents in the rotor through Faraday's induction principle, and those induced currents create their own magnetic field that interacts with the original rotating field. The rotor gets pulled along and spins and follows the rotating field, just as the tides follow the moon. No brushes, no commutator, no sparking, no wear, just rotation, emerging naturally and inevitably from the physics of alternating currents, out of phase with each other. I had solved the problem that haunted me for years. What I built in my imagination in Budapest, I reproduced exactly when I finally constructed the motors in my laboratory, and they operated precisely as I had foreseen, without any difference between the mental version and the physical one. Professor Poeschl called this impossible, and the established authorities declared it could never be done. The implications extended far beyond the motor itself, and thinking carefully about what this discovery meant for the transmission of electrical power across distances reveals why everything changed. Direct current traps you with an insurmountable problem rooted in basic physics. Electrical power equals voltage multiplied by current, which means that delivering a certain amount of power can happen with high voltage and low current, or with low voltage and high current. The critical fact determining everything follows Joule's law. Energy lost in transmission wires is proportional to the current squared multiplied by resistance, so doubling the current loses 4 times as much energy to heat. Edison's system generated at low voltage because that was safer for consumers. But low voltage means high current for meaningful power, and high current means tremendous losses in the wires. So much power wasted as heat after a mile or two that the system became impractical, which forced Edison to build power stations every mile, 1 station for every neighborhood. Alternating current changed everything, because the current alternates in smooth sinusoidal waves and can pass through a transformer. A transformer is a remarkably simple device consisting of just 2 coils of wire wound around a shared iron core, and the alternating current in one coil induces an alternating current in the other, with voltages and currents in different proportions depending on the ratio of windings. Stepping the voltage up for transmission and stepping it back down for use became possible, and high voltage means low current for the same power, while low current means minimal losses in the wires. Generating power at a convenient voltage, stepping it up to hundreds of thousands of volts, sending it across hundreds of miles with almost no loss, and then stepping it back down wherever needed became the new reality. One generating station could serve an entire city, and one dam harnessing the power of a great waterfall could illuminate a region. America received me in 1884, with these ideas packed alongside 4 cents in my pocket, a few of my own poems, and calculations for machines that would transform the world. My brief work for Edison at his machine works in Manhattan ended because our methods were too different and our visions incompatible. He remained committed to direct current and the investments already made, while I knew that alternating current was the future. My work eventually came to the attention of George Westinghouse, a man of vision and courage who had built his fortune on railroad air brakes and understood the value of systems that could scale. Westinghouse purchased my patents for the polyphase alternating current system in 1888 for $60,000 plus royalties, and that's when the battle between the two systems began in earnest. The battle the newspapers would call the War of Currents. The opposition from Edison's General Electric, backed by J.P. Morgan's financial empire, took the form of campaigns built on fear and misinformation. They claimed that alternating current was deadly, and that the high voltages required for transmission would kill on contact. Public demonstrations designed to horrify became their tactic, and they supported the development of the electric chair using alternating current specifically to associate my system with death. Even Lord Kelvin, one of the most respected physicists in the world, initially expressed skepticism about alternating current for power transmission. The mathematics were undeniable, though, and the physics could not be argued away. All that was great in the past was ridiculed and condemned and combated and suppressed, only to emerge all the more powerfully and all the more triumphantly from the struggle. My alternating current system won the contract to illuminate the world's Columbian Exposition in Chicago in 1893, one of the greatest world's fairs in history. Westinghouse bid $399,000 against General Electric's $554,000, which demonstrated that alternating current was not only superior but cheaper. 200,000 incandescent lamps blazed to life, powered by my polyphase system, and transformed the White City into a palace of electric light, visible for miles. I gave demonstrations there showing how alternating currents of high frequency could pass through the human body without harm, how tubes of gas could glow without wires, how the very air itself could carry electrical energy. 27 million visitors saw the future laid out before them in brilliant illumination, and Lord Kelvin visited the fair and left converted to the cause of alternating current. Niagara came next. Engineers had dreamed for years of harnessing the tremendous power of Niagara Falls, and an international commission examined proposals from around the world. Lord Kelvin himself chaired the selection committee, and they chose my system. Power generated at Niagara Falls traveled 26 miles to the city of Buffalo through 3-phase transmission lines operating at 11,000 volts on the 16th of November, 1896, marking the first time in human history that electricity had been transmitted such a distance for practical industrial use. The aluminum reduction industry was born at Niagara that year because those processes require massive continuous electrical power for electrochemical processing, and only my system could deliver what they demanded. The metal in every aircraft, every smartphone case, every kilometre of electrical wiring traces its affordable production to that moment. The great enterprise at Niagara represented not only a bold engineering feat, but a giant stride for humanity. And its success became a signal for the utilization of water powers all over the world, with an incalculable influence on industrial development. Today, the entire world runs on alternating current. Every generator, every transmission line, every motor spinning in every factory, every appliance in every home operates on principles I conceived in that Budapest park. The electricity powering your lights and your machines and your civilization pulses at 50 or 60 cycles per second, frequencies standardized in the years after my patents and embedded permanently in global infrastructure. Every electric vehicle charging station uses power electronics to manage alternating current from the grid, and every wind farm feeding renewable energy across hundreds of miles relies on transformers and transmission principles I established. Every solar installation converts direct current from photovoltaic panels into alternating current for transmission, because my system remains the most efficient way to move electrical power across distance. The unit of magnetic flux density, the Tesla, bears my name in every physics textbook, every MRI machine, every specification for electric motors. The IEEE, with over 400,000 members in 160 countries, traces its origins to the institute where I first presented these ideas. My polyphase system had one limitation I never fully solved, though, which is that it requires continuous generation matching consumption. The grid must produce exactly as much power as is being used at every instant. Today's engineers struggle with this same constraint as they integrate intermittent solar and wind power, and the future may require something I never imagined. A marriage of Edison's philosophy of storage with my philosophy of transmission. The ultimate system may honor us both. The path from vision to reality is never smooth. The inventor is often misunderstood and unrewarded, and the present belongs to those with power and influence and established interests. The future belongs to those who see what others cannot, who persist when told their ideas are impossible, who understand that instinct transcends knowledge. Let the future tell the truth and evaluate each one according to his work and accomplishments. The present is theirs, but the future, for which I have really worked, is mine. Every time you flip a switch, every time a motor hums to life, every time you benefit from electrical power transmitted across miles of wire, you witness the triumph of an idea once declared impossible. You live in a world shaped by what I saw in a Budapest sunset while reciting Goethe, the rotating magnetic field, the polyphase system, the cyclic nature of all energy made useful. The progressive development of man depends vitally on invention as the most important product of the creative brain. Its ultimate purpose is the complete mastery of mind over the material world and the harnessing of the forces of nature to human needs. Electricity is not merely a force to be exploited, but a window into the fundamental rhythms of the universe itself. The pulse and wave and alternation that underlies everything we see has been made visible and useful and brought into the service of humanity. Nature gave us the pattern, and I simply had the eyes to see it.